Hello students, here is the question. The area bounded by the curve 4y square equal to x square into 4 minus x into x minus 2. So here we have this curve, and first we need to find out this curve is present in what domains. So if you look over here, 4y square is positive always because this is a square term, okay, and the 4 is a constant which is also positive. So if we look over here, this term over here, 4 minus x minus 2, has to be positive 2 because they are in this format. So this entire equation over here has to be positive. So I can say x square x minus 4 x minus 2 has to be negative, or if I just remove this negative sign over here, this has to be negative, correct? So if you look over here, the points at which the curve y 4y square becomes 0, that is y becomes 0, is x equal to 0, x equal to 2, and x equal to 4. So once we have that, we just have to take out the places where this case becomes positive. We just have to take it out of the cases. So once we have that case, we get the curve equation, also the curve diagram to be this. This is the curve. It has two end points, and this has equidistant points. Take it any point. At this x, let's say the y is the same. Similarly, at this x, the y is the same on both the sides, positive or negative. So once we have that, we just take the 4 in the denominator. So the equation becomes x square by 4, 4 minus x minus 2, correct? And we have y square in the left hand side. So we take the square root and we get the equation for y, which is given to us on the right hand side over here. As you can see, this is the equation that we get. We have the square root for both these multiplication and x as it is. We take the integration from 2 to 4, and as we saw, there is a 1 by 4 in the new square root, so we get 1 by 2 outside as it is a constant. And I'm doubling the area because in 2 to 4 the curve is present in the positive y and also in the negative y. So the curve has area similar but in the both the y domains. So I double it, and to simplify this integration, I put x is equals to 4x sine square theta plus 2 cos square theta. Once I put x equal to that, I get dx to be equal to this, and this is what I get. But then I put in the values in the integration, solve the complete integration. Over here, as you can see, the x value is put over here, the the 4 minus x and x minus 2 is formed, and this is what we get at dx. Once we solve it, we use Wallis theorem over here, and we get the value to be 3 pi by 2. Thank you.